have to break up. And now I should be able to continue what I was talking about last time. And right at the end of the last lecture, I was about to tell you how to make amides. Do you remember that amides? Amide will come down to that point where the two substituents of the nitrogen can both be hydrogens, or just one can be hydrogen and the other can be carbon, or they can both be carbons. And if they're both carbons, the carbon pieces can be the same. They can be ethyl groups or ethyl groups, benzene rings and so on, or they can be different. So there's quite a variety that one can actually make. Now, how does one make amides? Well, one of the ways is from acid chloride. You take an acid chloride and you treat it with an amine that has at least one hydrogen on the nitrogen, then what can happen is what does happen is that the lone pair on the nitrogen attacks the carbonyl of the acid chloride in the normal way, because you've seen this sort of business before, where a nucleophile attacks the carbonyl carbon. And now, two things will happen. One is negative charge can come out and expel the chlorine, the chloride rather. And the chloride can remove one of the hydrogens. Hello, sir. Can you perhaps get this thing to work? Just a few minutes ago. See, nothing. And here it's all switched on. Yeah, that's maximum, you see. But that should be mute. This reaction works better than the microphone. Now, why is it that the nitrogen must have at least one hydrogen? Well, the reason is that if you have a tertiary amine, in other words, let's just take one. Let's take
Check. Yeah.
I'm sorry,
I think the podium mic on and then back wireless. So
A lot of calls are from this
it just rose up. So the panel does that. Freeze up every once in a while.
Okay.
But it's working. Thank you very much.
Why is it when I stand over here, there's a feedback? Can you see it's useless?
Keep trying it.
I'm testing this to see if it is still useless.
The speakers are right above you, so
Well, they need to be moved, obviously, but we don't have time now. Okay, thank you very much, sir. Okay, now I hope, let's just adjust the button. I hope I can continue. Supposing we have a tertiary amine that can expel, or not expel, that can attack the carbonyl in this way. and then you get a plus charge on there. And then you get this species. Now this species isn't an amide, because an amide has to have on the nitrogen no charge. You see, here's the general picture of an amide. The nitrogen has 3 bonds and no charge. Here, the nitrogen has 4 bonds and a charge. So it isn't an amide, so you don't make amides that way. Now let me give you a more complicated example, a specific example as well. So instead of using generic groups R and R prime and so on, let me show you how to use this information. Supposing that you want to Supposing you wanted to make that amide. It looks a funny amide, but there's nitrogen with 3 bonds attached to a carbonyl, so it is an amide. The nitrogen has 2 extra carbon bits on it, but they happen to be joined together. Big deal. It's no different from, I'll just write this up temporarily. If I wrote that amide down, you'd all be comfortable with it. But all I've done is to have these 2 carbons joined together. So that's an amide. And supposing you wanted to make that amide, and you wanted to make it from this alcohol. Well, the way to find out or to work out how to do that is to ask yourself, what ways do I know of making amides? One of the ways that you know is to treat an acid chloride with an amine, having at least 1 hydrogen on the nitrogen. So that would be the acid chloride that you would treat with the amine. Now you've got a new problem. How do you make an acid chloride? Well, you know how to make an acid chloride. If you treat a carboxylic acid with thionyl chloride, you get an acid chloride. So now the problem changes again. How do you make this acid? Well, one of the ways of making an acid, which you know about, is to oxidize an alcohol with chromic acid. So you see, by working backwards, you can write down a reasonable synthetic route to make the amide that you want. And the trick in doing this is simply to ask yourself, what's the nature of the product I want? Well, it's an amide. I want to make it. Do I know any ways of making amide? Yes, one of the ways is take acid chloride plus amine. In the case, which amine should I use? Which acid chloride should I use? And so the problem then becomes how to get your hands on the amine and the acid chloride. Now, if the acid chloride isn't available, you ask yourself, how do you make the acid chloride? You make it from an acid. So you get to here. And then, since you're given this as the starting material, you have to ask yourself, how do I convert an alcohol into an acid? And you had that. You oxidize it with chromic acid. Another way of making amides is to take an acid anhydride and treat it with an amine, again having at least 1 hydrogen on the nitrogen. And once again, the carbonyl group is attacked. And if you follow that through, you will end up with your amide. So all of these things are very, very similar in mechanism. The nitrogen attacks the carbonyl of a suitable reagent, which could be an acid chloride or an anhydride. In the case of an acid chloride, the leaving group is Cl-. In the case of an anhydride, the leaving group is the salt of the acid. So if R is methyl, this would be acetate. Now, I've used generic symbols there. Perhaps I can show you a specific example, but a more complicated one. If I take this anhydride, all it is a cyclic. It's a cyclic anhydride. There's nothing funny about it. I better draw it more uniformly. It's not a very pretty picture. See, the anhydride, a very common one, is acetic anhydride. By taking 2 moles of acetic acid and removing the elements of water, you get this. But all I've done in making that is I've joined this carbon with that carbon. So I've got a cyclic anhydride, still an anhydride. Now, if I treat this compound with ammonia, so this is a nitrogen compound with at least 1 hydrogen on the nitrogen. It's the simplest amine. If I do that, then the carbonyl group will be attacked, and the electrons will come back and expel the other half of the anhydride. And after the whole thing has been done, you will end up with this compound, which you see is both an amide for the top carbonyl and an acid for the bottom carbonyl. Now there is one other preparation of an amide that we need to know about. In the examples I've given you so far, we have taken an acylating agent, in other words a compound with a carbonyl group stuck on carbon and some sort of leaving group on that carbonyl carbon. In this case it's an acetate or a propionate or something like that. It's a carboxylate. Earlier I talked about having a chlorine here, so chloride is the leaving group. But there's one other one, and that is if you treat an ester with an amine, then you can also get an amide, and I need to show you how to do that.
So fast, like it was open at like 10:30, and at 10:30 when I logged on, it was full. Like, what is this? I have me and Melanie, yeah, me and Melanie are both trying to get into it, but it's so. Do you need it? It's just like a class. Well, I do because they recommend that you take it, and I actually like it. so I'm taking it as my major. Like bioscience. So I'm pretty much doing what an honors biochem student does, but I don't even get to say I'm an honors student.
Can you get into the program though?
Yeah, but I like being in education.
Oh.
Nice people. Did you become 35 second semester than I did?
With dinner, that's all I remember.
Did you have like the
Never had the gay booth.
okay? Because I was just gonna be like, yeah.
He wasn't gay. His name was gay.
I know.
Just like he's a teacher. He like took us by right now.
Oh,
I guess maybe he liked it.
if you actually find a copy you like.
Okay, that's quite a long mechanism, so I need to sort of talk you through that. The general principle is exactly the same as everything else I've been telling you. There's a nucleophile, which happens to be nitrogen, that attacks the carbonyl carbon in the normal way. That puts electron density on here, and a plus charge on the nitrogen. And then the essential thing that happens is that the electron density comes back here and expels the O-ethyl group. And if you follow that through, you get the final product. The details of how it happens are probably that because this proton is on a positively charged entity, it loops onto this negatively charged entity. You've got something that's neutral. And now, this lone pair of electrons could push this out, or this lone pair of electrons could push it out. But nitrogen is better than oxygen at pushing adjacent pieces out. So the lone pair probably does this, pushes that out, and then the lone pair moves this way, and finally the ethoxide pulls off a proton. But the essential point is that the nucleophile attacks the carbonyl to give you something like this. And then the ethoxide is expelled with regeneration of the carbonyl. So if you want an amide, you can make it if you've got the amine and an appropriate ester. And usually something like a methyl ester or an ethyl ester is very suitable. Mainly because those esters are very easy to make and they're actually easy to handle. Acid chlorides are not so easy to handle. They're extremely reactive, and if you leave them in moist air, they will hydrolyze. The chlorine will be replaced by OH, whereas esters are much more stable. But then they react less easily with amines. But usually you can get over that just by heating the ester with the amine or leaving it for a long time. Whereas if you're using an acid chloride, which has Cl- as the leading group, you can do the reaction at room temperature or even at 0 degrees. So there are various ways of making amides. Now, one thing that we need to next talk about is how to hydrolyze an amide. Now, some time ago, I rather quickly went through how to hydrolyze a nitrile. And I showed you that ultimately from the nitrile you get a carboxylic acid, which is what you expect because a nitrile and the carboxylic acid have that carbon at the same oxidation level. In the case of a nitrile, the carbon's joined by 3 bonds to an electronegative atom. In the case of a carboxylic acid, the carbon is joined by 3 bonds to oxygens. A single bond to oxygen and then a double bond to an oxygen. There's 3 bonds to oxygen. So the oxidation level is the same. So if you hydrolyze a nitrile, you should get an acid, which you do. And I went through the mechanism. And that was the first time, I think, that you'd seen quite a long sort of series of air pushing mechanisms. And I told you I would go through it again. And I will now go through it again, but in the, I go through something very, very similar. I will tell you how to hydrolyze an amide, which is one of the intermediates when you hydrolyze a nitrile. You take a nitrile, hydrolyze it, first you get the amide, then the amide hydrolyzes further. So let's have a look at how that works.
Next Saturday. But it's so late. Like, it just keeps getting later and later.
Or next Friday. I have a feeling like something's going on Friday. Next Friday. I don't know what. Health and wellness. What is the health and wellness? That's on Sunday.
Some of you may be wondering why does one need to know quite a lot about amides? Turns out they're very important.
I think it's
Many medicines have amide groups in them. In fact, the famous medicine penicillin is a special type of amide, non-reactive amide. So let's see how we can hydrolyze an amide. And you can do it in 2 ways, either using an acid or a base. Let's do the acid one first. Let's take this amide and treat it with acid. So the first thing that will happen, or one of the things that will happen, is that the oxygen will be protonated. Now, as soon as that happens, this carbon becomes very electrophilic, because you can write a resonance structure in which there's a plus charge on that carbon. And so water can now attack that carbon. Now you've still got water there, which can remove one of those protons. It's all reversible. Oh, sorry, I got the wrong thing now. So now we get that. And now, because we're using an acid, one of these heteroatoms can be protonated. In fact, they're all protonated, but the nitrogen is protonated to a much greater extent. Nitrogen's more basic than oxygen. And so the important protonated species is this one, and then one of these 2 oxygen lone pairs pushes out the protonated nitrogen. And this proton is finally removed. So that is how to hydrolyze an amide in an acidic medium. And supposing you're using HCl, you will then get ammonium chloride. So this again is an example of a nucleophile attacking a carbonyl group. if we go back to the beginning here, we're doing this under acidic conditions. Now what acid will do is to protonate one or other or both of these heteroatoms. It actually protonates both, but very largely the oxygen. And the productive pathway is one that follows protonation on oxygen. So what do I mean by productive pathway? If you take a compound and you expose it to some reagent, let's say the reagent is very simple, suppose it's just a proton. The proton bumps into the molecule, to various parts of the molecule. Very quickly it just bumps off, like throwing a tennis ball at a wall. Occasionally it will stick. Those times when it sticks, it may hang around for a while and then come off again. Sometimes it can stick in various places and also come off again. But sometimes, depending on which place it sticks to, something further can happen. And in this case, although protons will bump into here and there, the productive pathway, the pathway that leads to something happening, what you observe, namely formation of the acid, is when it sticks onto the oxygen. Once it sticks onto the oxygen, this carbon becomes very, very susceptible to attack by nucleophile. You're doing this in aqueous acids. There's a load of nucleophile around. This attacks, gives you this. You can lose a proton from that oxygen, and because it's in acid, you can protonate this nitrogen. You can also protonate that. But the productive pathway is protonation of the nitrogen. Then one of these lone pairs pushes out the protonated nitrogen to give you the acid. So that's the mechanism for hydrolyzing an amide using acidic conditions. But there's another way of hydrolyzing an amide. Instead of boiling it up with hydrochloric acid, you can boil it up with aqueous sodium hydroxide. In other words, you can use a base. So let's see how that happens when you use a base.
What is he going over now?
Hydrolysis of an amide. Maybe we shouldn't do anything for Raymond. After they already buy something.
It's just because, like,
I know, but deep down, Steven doesn't care. I'm sure he doesn't.
Did he say anything else?
Like, to hear, because if we do it on a Friday, we can't go anyways.
no.
Who's invited on Friday? Like two of the rich ones.
So, yeah, I guess. A bunch of orange cans. And a few of us.
So once again, we're dealing with attack of a nucleophile on a carbonyl. Here the nucleophile is a strong nucleophile, it's hydroxide, attacks the carbonyl to give you this. This can also lose a proton, this hydroxyl, and then one or other of these oxygens can expel NH2 minus to generate a carboxylate, an NH2 minus, which can remove the proton from water, give you ammonia and sodium hydroxide. And if you smell the reaction mixture, you'll smell ammonia coming off. experiment involving ammonia that was done in a fishing town in England. People wanted to find out how fresh fish is. And you can buy two types of fish in England, either frozen fish or fish that's not frozen but delivered to the market. So they did an experiment in this fishing village. They got the wives of the fishermen to cook samples of various fish, some frozen, some fresh, and people had to eat this stuff, probably with French fries, salt, vinegar, delicious, and make an evaluation as to the quality. And they also took samples of the two types of fish and determined how much ammonia is present, because the less fresh the fish is, the more ammonia. And it turned out, you might think that buying fresh fish at the big fish market was the best thing to do, but it turned out that the frozen blocks of fish were significantly fresher. The reason is that those are made on the ship, on the trawlers, where the fishing is done, so the fish are frozen when they're really very fresh, whereas the other fish travel around a lot till they get to the big fish markets in London. So that was kind of interesting. So now I switched to frozen blocks of Atlantic cod. Okay, I told you how to hydrolyze an amide, and you can do it in two ways. What I want to do is to very quickly remind you about hydrolysis of nitriles.
There's something else.
Remember which email it was that said that what the date was? Because like I have this one with the 4 announcements.
It was like right after your meeting, wasn't it? I mean, the meeting on Monday?
Oh, was it?
I think so. Or maybe she didn't email, because she started talking to me on Gmail chat, and I was like, oh god.
I have my
Whatever, you stop for like 1 minute.
Now you can see that what you get from a nitrile is in fact an amide. And a few minutes ago I told you what happens when you boil an amide up with aqueous acid. It's hydrolyzed to a carboxylic acid. And so this, as before, ultimately goes to the carboxylic acid. So when you hydrolyze a nitrile, you first convert it to an amide, and then the amide is converted, again by hydrolysis, into the carboxylic acid. And you can do that by just boiling the nitrile up with dilute acid, like dilute HCl. Alternatively, you can boil the nitrile with aqueous alkali, sodium hydroxide solution. Exactly the same thing happens. So let me show you that. Should I write it back again? Okay.
It's called.
One of the things I should tell you is that proteins are amides. And if amides were very easily hydrolyzed, you know, if you put them into water and they were hydrolyzed, you would be in big trouble. Because all the proteins that we put into water would decompose.
Ray's invited to Lobby. He's not. See, I assumed he was. That's why I was like, it's okay though. Like,
Last time I checked the events, I didn't see might have been. I don't remember.
I didn't know if they were friends. That's why I was like, what?
So once again, you get the amide, and that is hydrolyzed further. So you can hydrolyze nitriles either by acid or by base. Now I'm going to change gears. I'm going to talk about the loss of carbon dioxide from certain carboxylic acids.
So many mechanisms. Definitely.
Okay, let's wrap it up again.
Loss of carbon
What
dioxide.
did I do?
What is he doing now?
He's just reading. I know. Yo, do you have theories in education?
It's on like either the first or second floor. It's like you just walk down the hallway like you would. I think it's the first one actually. But
Do you squeeze it? Does its eyes pop out?
that's so cute.
And then while I'm waiting, and then you decided when you'd like a very big help session for me to go over the details of the exam. When a mail class is done, the 7th of December, what day of the week is that?
Wednesday.
Wednesday, okay. So, wait a second. Do you want it the same day?
No.
On the 3rd or the 8th?
It's gonna be like hours long.
The 9th?
7. 9. I'd rather have it.
wait, never mind. I have my final on Wednesday.
Okay, the exam
My
I
night
think
class.
is on the 15th. Okay, so the exam's got to be before the 15th. I would prefer not to have it on Wednesday the 7th because I've lectured for an hour and I'm going to lecture for 2.5 to 3 hours to go over everything.
Yeah, but in the daytime.
Alright, so we can't have the Wednesday then. Okay, so Wednesday is out, that's good because I'm not too keen. What about the Thursday?
Okay, wait. I don't know if he's even invited though.
I'm checking.
Okay, there seems to be quite a show of hands for Thursday. What about the Friday? Hardly anything. Okay, so far Thursday wins. Then Saturday...
Are you kidding me? No.
I have a final the next day. Monday, I have a final on Monday.
What about Monday the 11th? The 12th?
Oh, just go with either the 8th or the 9th.
What time? Thank you.
So it's going to be Thursday the 8th then.
What time? You do it in the morning?
Sorry?
Yeah,
Morning.
like daytime.
It can be either in the daytime or when it's dark outside. What would you like? Okay, hands up for daytime. Hands up for night time. Are you all scared of the dark? Okay, so to be during the day, probably it's most convenient to have it at 1. Because then, you know, I can lecture for 3 hours. So why don't I write down?
And I'm skipping this week. So I should be able to one. Like technically, I get like this Thursday because it's 5:30, yeah, 6:20, but then I
Okay,
plus
let me continue now with this.
Wait, are you taking Korean? Is that what your night class? Is that your night class? Yeah.
So I have my final on the last day, like Wednesday.
Okay, I want to talk about certain
I
types.
said yes, he's in.
This is all the people that were.
I want to talk about certain types of reactions in which carbon dioxide is lost from an acid.
Byron said he's invited though.
He's invited to. Frank invited him, but Yaya didn't. Does that make sense?
Oh, that's even more awkward. Okay, well, this is what Byron said.
During the day. Like, oh, one, sorry.
He told you
If
to
you have
cancel?
an acid of that type and you heat it, this is called a beta-keto acid. If you look at the structure, you can see that it is a carboxylic acid. It has CO2H, and it also is a ketone because it's got a carbonyl group, and the carbonyl group in the beta position carries 2 carbons because R is going to be methyl or cyclohexyl or benzene rings or something like that. If you heat these acids, they lose carbon dioxide. And the question is, how do they lose carbon dioxide? The answer is this. If I rewrite the beta-keto acid in this way, this is what happens. You can see that by writing the beta-keto acid in this way, I can draw a cyclic reorganization of the electrons. I can draw all these little curly arrows in this way to release carbon dioxide and to give this substance, which is an alkene and also an alcohol. Now you know that the names of alcohols end in OL, and you know that substances with carbon-carbon double bonds are called alkenes. So this is an ene and also an ol. So it is then an enol. And those enols usually are not very stable. It's very rare that you can put one of these in a bottle by itself. What happens is that they change into a ketone. The formula is the same, and you can see how it changes. The electron density moves this way, electron density moves out here, picks up the proton is lost from there, and as the electron density moves this way, you generate the carbon here. And as you pick up the proton at the end here, you generate the carbon. So this process is one that occurs very easily. The enol goes to the ketone. And I will say quite a bit more about enols and some related species quite soon. Now what I'd like you to do is I'd like you to do some homeworks. And these are the questions that I want to give you.
Is there anything going like
He probably would if they were like, yo.
I don't understand why. But me and Francis have the same problem.
because if he doesn't show up, then it's like, well,
Not really though.
whatever. Oh, like what day is that? Why is it so complicated?
And I know next week would be really late, but it's just like, it would just release so much like headache from trying to decide it. Oh, there's so many questions.
Oh my god. But why would Frank invite people that she didn't have on her list to surprise her?
Oh, that's A to E. I was wondering what he was writing. Oh, and he just erased that. Because
It's a completely different chapter.
So you notice how for the event I made for Frank, I didn't invite him.
Yeah.
Okay, I think probably before I start talking about
Wait, to surprise Frank.
enols,
At Yaya's party.
then probably it's best for me to start next time. Okay.